Hi folks, I'm going to talk you through how to do one of the course assignments running the syntax file for standard multiple regression for one of the course assignments. So here is that syntax file here. I've already filled in the variables. I'm going to use the data set from Pitts et al. This is a data set of, I believe it's combat medics. And we're going to focus on the depression variable as the dependent variable, and our two independent variables are going to be combat and threat. As we look at the data set, we see there's no missing data and there are 324 cases. I'm starting off with a brand new output file, which is really important. So basically what I've done is I've typed in my variables. Where it said your DV, I typed in depress. Where it said your IV, I typed in my independent variables with a space in between, and I'm reading through the syntax as I'm doing this, and then I'm going to run it one section at a time, which is how I recommend you do it. So let's do that first section. We're going to include these comments so that they appear in our output file, because then we're going to annotate the output file. These comments are going to guide us as to what each section is about. So let's run that first section. We're going to go here because we have continuous IVs. I don't have any categorical IVs, so I'm going to skip that output. So I'm going to do this first section and hit the green arrow, and here it is. So I've got my comments and I've got my initial getting to know my data. I'll be annotating this later. Now in this case, these tables are really long, these frequency tables, and we don't really need them. So what we really need is this statistics table. So I'm going to go ahead and click on this frequency table output by clicking on the yellow box, and I'm going to hit delete, or you can hit edit and cut, and that will also get rid of it because I don't need all of that output. I'm really looking at here is just getting to know my data, seeing what my sample size is. Are there missing cases? If I knew these scores better, I would be able to tell is the minimum and maximum within the expected range. So I've done that part. Now I'm going to go back to my syntax file. I have no categorical variables, independent variables. I'm going to skip that. I don't have any missing data, so I'm going to skip that as well. Most of the data sets you're working with don't have enough missing data, so you don't have to run this missing values. I am going to run my univariate outlier section, and again I've already input my dependent variable and my two independent variables, so I'm going to highlight that section, again hit the green arrow, and now I have here in my output file, this is my univariate outlier section. So what I'm going to note are possible outliers, so I can see those most clearly in the stem and leaf plots with the extremes on either end. I can see them to some degree in the histogram, and then the other place I can see possible outliers are in my box plots. So I'm going to annotate that output when I export this output file. So that's univariate outliers. Next, I'm going to look at multivariate outliers. So this syntax here is going to run a regression for the sole purpose of computing and saving the Mahalanobis distance statistic. If that Mahalanobis distance is above a specified cutoff, then that indicates an outlier, and that's what these comments explain. So in my case, I have two independent variables, and this is only for continuous IVs. So however many, you have to have two or more continuous IVs to need to run this section. The cutoff for two continuous IVs is 13.816. So I'm going to run this analysis. I'm going to run it down to line 99 first to compute Mahalanobis distance, and that's what I've done here. So I can look at my data set. There it is. If I wanted to, I can sort my data set, and I can sort it in descending order based on Mahalanobis distance, and I can quickly see I have one case above this cutoff for two continuous IVs. The cutoff is 13.8. So I have one potential multivariate outlier that I'm going to address later. I can also run this output here to just get a table, which is similar to sorting. And here I can see in my extreme values, this is all I care about. I have one case above the cutoff, and that's really all I'm interested in all this output. That's the only thing I'm going to annotate. Okay, and now I go back to my syntax file and I'm going to assess the normality assumption for my DV and my two IVs. So I'm going to highlight this section because I have only continuous IVs. So I'm going to run it. And in this section, I am only going to, in this section, I am going to focus on normality. Now, once again, because I have this large data set, I don't need these frequency tables. So I can click on this yellow box and I can hit delete on my keyboard or edit cut and get rid of that. So we don't need that, and it just shortens the output for us. So here I'm going to note the mean, median, mode. How close are they to indicate normality? I'm going to look at my skewness and kurtosis. Are they within positive, -1 to assess normality? I'm going to look at my histograms, and down here there's repetitive outputs, but you only have to look at it one, or you only have to annotate it one time. I'm going to annotate my Kolmogorov-Smirnov test. If it's significant, if it's below 0.001, that means that my data is significantly different from a normal distribution. Here it is not significant, meaning my data is not significantly different from a normal distribution. I'm going to also annotate my normal QQ plots here. And that's going to be the focus of what I look at in my normality. I don't have any categorical IVs. If I did, I would run this syntax here. So you're not expected to do any transformations if you do have data that is that deviates from normality. If you have to recode a variable, which we don't, there's instructions here. There's a how-to video on how to do that. I'm now going to move on to my assumption of linearity. I've put in my dependent variable and my continuous independent variables 2 times, once for correlations and once for the graph. So I'm going to run this output, hit the green arrow, and here I'm paying attention to these correlations, making sure that my IVs are significantly correlated with my DV. Actually, one of my IVs is not, so I could choose not to include it. I am going to include it, but this could be a reason for not including it. And then here you're looking at whether the data clusters around the line, the regression line, and for depression. So here we can see it's a little less obvious for combat, although there's some clustering around the line, and then for threat, for perceived threat, there's some clustering around the line. It's not a strong correlation, but it's linear as opposed to curvilinear, so we're okay there. Here I have just some comments that I want to have in my output file about homoscedasticity and where to check for it. The next command I'm going to do is for multicollinearity, where I'm just going to look at correlations between my 2 continuous IVs. So I'm going to run that. And here I just have those comments so I remember as I'm annotating my output. And here I'm just noting that threat and combat experience are not too highly correlated. So if they're not 0.80 or higher, then probably these variables are not multicollinear, so we can include them both. Once again, I go back to my syntax file. I have more assumptions that I'm going to add in. I'm going to run a power analysis. So I'm going to go ahead and include this. So I have the comments in my output file, and I remember to do the power analysis. And I don't have any demicoding, so I'm going to skip that. Now I'm at centering my variables. Typically, we like to center our continuous independent variables. So I've put in my dependent variable and my 2 continuous independent variables, and I'm going to highlight through here. And I'm just going to run that. The only part of this output that I'm interested in are the means. So when I look at this, so here's where I ran it centering. The only part of this output that I want are these 2 means. These means are based on the full regression sample. So as I create my centered variables, I'm going to use those means. So I have a compute command all set up. I already copied and pasted it again before the video. You're going to see it just once in your syntax file. And basically, I'm going to just take it one step at a time. So my first variable is combat. So I'm going to type in the word combat because I'm renaming a new variable, but it's based on the old variable combat. And what I'm going to do is I'm going to subtract this mean 9.51 from every score of combat in order to center it so that 0 equals the mean. So if someone's combat score is 9.51, 9.51 minus 9.51 is 0. So centering just puts the mean at 0. I'm going to do the same thing for threat. And I'm going to type in my threat variable here. In this case, the mean of threat is 38.58. So I'm typing it in here. And now I am ready to go to run and create a centered variable. And I see here there's no errors. I'm going to look at my data set. And here I have my centered variables that I'm going to use in my final analysis. An interaction term is optional. You would create an interaction term by multiplying your two centered variables. We're not going to do that. Finally, we are at our final analysis. So I've already put in my dependent variable, my two centered variables. But what I'm going to do first, because I have a Mahalanobis distance score above the cutoff, I'm going to go down here to where it says type in your cutoff value here. And for two IVs, the cutoff is 13.816. So I'm going to type that in twice here, and I'm going to select out that case, 13.816. So I had that multivariate outlier. And so this is going to select that out. I'm going to run this, and what this does is it finds that case right here, puts a slash so it will not be included, and I now have 323 cases in my data set. Now I'm going to run my final analysis with that case deselected. So now I run my final analysis. Here it is. I have my final analysis here, and I'm going to annotate all this as my final analysis. I see that the model is significant. The model is significant here based on the ANOVA and also based on the model summary. We're only predicting about 8.2% of the variance or 7.7% of the variance for the adjusted R-squared. So, it's not predicting a lot, but it is significant. And I have my coefficients here that I'd look at. So I have a significant threat coefficient, but combat is not significant. And I would also look at my tolerance and VIF to check for multicollinearity and see if that exceeds the cutoff. And I would also look at my case-wise diagnostics. We typically don't want cases that are above two standard deviations or standardized residuals greater than 2. We have a couple of cases here. If I wanted to, if this was my dissertation, I would rerun it and eliminate these cases. Here is the normality check that I'm most interested in. It's the regression of this. It's the normality of the standardized residual. So this tells me that my data is pretty normally distributed. The normal PP plot also tells me that for my model as a whole, my data is pretty normally distributed. And for homoscedasticity, these dots are pretty evenly distributed above and below the 0 line. So my data is pretty it has homoscedasticity or equal variance. And then I have one more piece that I'm going to run, which is just this last residuals check. So I'm just going to run that here, and it's going to run one more thing, and I'm going to include all these comments all the way down to the filtering. So this is the last residuals check to see if I have any outliers or any dots really far out. So there might be a couple here, but overall this indicates no serious outlier cases. And again, there's an output file that goes through this, as there is with all of this syntax. So that's how I've run my entire analysis. I, in the process, have created these predicted and residual variables, predicted scores for my dependent variable, and the residual scores for my dependent variable. If I need to rerun for any reason, the parts that I just ran, you would need to delete these two variables. If for some reason you are going to rerun your analysis, delete these two variables and then rerun your analysis so that you create new predicted scores and residual scores based on your most recent analysis. So you have lots of output to check. Thank you so much for your attention.